Dear students, today we are going to discuss the concept that is second order derivative. Up to last lecture we have completed the exercise number 3.5, the derivatives of parametric functions. Okay, now what is the meaning of second order derivative? So see here, consider a differentiable function y is equal to f of x. Then always you will get dy by dx. After differentiating y with respect to x, we get dy by dx. It is denoted as f dash x also. Derivative of f of x is written as f dash x. And that derivative is called as first order derivative. That is, here it is the first order derivative of y with respect to x, because y depends on x. So we get the derivative of y with respect to x. And how it is written? It is written as dy by dx is equal to f dash x. And it is also denoted by y dash or y1. So these symbols are also used. So if f dash x is differentiable function of x, now suppose we get dy by dx is equal to f dash x, and again f dash x is also differentiable, then you can take the derivative of dy by dx. See here it is written as d of dy by dx with respect to x. So again if you take the derivative of that dy by dx with respect to x, then it is denoted by d square y upon dx square, or it is also written as f double dash of x, and it is called as the second order derivative of y with respect to x, and it is also denoted by y double dash or y2. Okay, and again if that f double dash x is differentiable, and if you take the derivative of d square y upon dx square again, then you will get d cube y upon dx cube, or you can write f triple dash of x is called as third order derivative of y with respect to x, and it is also denoted by y triple dash or y3. So you can continue this process again and again n times. Okay, again means first order derivative, then second order, then third order, and so on like this up to nth order. But here for our syllabus only second order derivative is included. Means first you take the derivative of the given function and again you differentiate that with respect to x, and then you will get d square y upon dx square. That is the symbol used for second order derivative, or you can write f double dash of x, or it is also denoted as y double dash or y2. So today we will solve the exercise number 3.6 related to this second order derivative. So see the question number 1, that find d square y upon dx square if y is equal to root x, or y is equal to x raised to 5, or y is equal to x raised to minus 7. Then question number 2 is given, find d square y upon dx square if y is equal to e raised to x, or y is equal to e raised to 2x plus 1, or y is equal to e raised to log x, like this. Our all standard rules are as it is, just you have to take the derivative, means first order derivative, and again we have to differentiate that with respect to x. So you will get e square y upon dx square. So let us see now how will you solve. We will solve some examples now from the exercise 3.6. Now see the first question, means first function is given, that is y is equal to root x, and we have to find out d square y upon dx square. So in answer how will you write? Very simple. See, first of all we will differentiate this now with respect to x. Okay, so what is dy by dx? Very simple. Dy by dx, derivative of root x is, all of you know that it is 1 upon 2 root x. Now this is always we will call it as first order derivative. Okay, so just to understand, I have written first order derivative here. Okay, so this is dy by dx, that is 1 upon 2 root x. Now again we have to differentiate this with respect to x. Then you will get the second order derivative. Remember. Okay. So if I write differentiate with respect to x. Now again we have to differentiate. Then how will you write this? It is d by dx of dy by dx like this is equal to, now on the right hand side, now here 1 upon 2 is constant and we have to take the derivative of 1 upon root x. Okay, see this carefully. I have written detailed step here to understand. Now what will you get? To the left hand side you will get d square y upon dx square. Okay, this is just a symbol to express the second order derivative. Okay, because d by dx of dy by dx can be written as d square y upon dx square. Now it is equal to, this is 1 by 2. Now how will you get the derivative of 1 upon root x? Now 1 upon root x means it is 1 upon x raised to 1 by 2. Then you can rewrite this as, see here, I will write it is 1 upon x raised to 1 by 2. Now for our convenience to take the derivative of that, I will write it is as d by dx of x raised to minus 1 by 2. Just take that term x raised to 1 by 2 to the numerator, so that now you can apply the rule, basic rule of derivative, that is derivative of x raised to n. It is equal to n into x raised to n minus 1. If you use that rule, then what will you write here? It is minus 1 by 2 into x raised to minus 1 by 2 minus 1, like this. Okay, you can complete this by using that rule. Now finally what will you get? Here 1 by 2 into minus 1 by 2 is minus 1 by 4. And see the index of x now. By cross multiplying you will get it is minus 3 by 2. Now you can complete this answer. If you want to write the final answer, then d square y upon dx square will be minus 1 upon 4. Now x raised to minus 3 by 2 means it is, you can write on the denominator, that is x raised to plus 3 by 2. Now you can keep this as a final answer. So this is the concept of second order derivative. After getting first order derivative, again you have to differentiate the given function, means that derivative, with respect to x. So this is d square y upon dx square, that is equal to minus 1 upon 4 into x raised to 3 by 2. Now second one is y is equal to x raised to 5. And we have to find out d square y upon dx square. So y is equal to x raised to 5. Now differentiate this with respect to x first of all. Then you will get the first order derivative, that is dy by dx is equal to, now very simple, derivative of x raised to 5 is 5 into x raised to 4. Now to get the second order derivative, we will differentiate this again with respect to x. Then now I will write directly d square y upon dx square, because it is the derivative of dy by dx. So d by dx of dy by dx means d square y upon dx square, that is equal to, now it is very simple, keep 5 as it is and just you take the derivative of x raised to 4, that is 4 into x raised to 3. So totally you will get 5 into 4 is 20, so 20x cube. This is our d square y upon dx square. So very simple. Okay. Now we will complete a next question also, that is given that y is equal to x raised to minus 7. Okay. Now differentiate this again with respect to x. So now it is dy by dx is equal to, now by that rule, derivative of x raised to n is n into x raised to n minus 1. By that we get minus 7 into x raised to minus 7 minus 1, that is minus 7 into x raised to minus 8. This is dy by dx. And again if you differentiate this with respect to x, then you will get the second order derivative, that is d square y upon dx square. Now how will you differentiate this? Minus 7 keep as it is, and again you can apply x raised to n rule here. So by which you will get it is minus 8 into x raised to minus 8 minus 1, that is minus 9. And finally it is minus 7 into minus 8, that is plus 56 into x raised to minus n minus 9. So you can rewrite this as 56 upon x raised to n. So this is d square y upon dx square. So this is the total concept of the second order derivative. All rules are same, just you have to differentiate the answer, that is dy by dx, again with respect to x, so that you will get d square y upon dx square. Okay. So our topic is completed now. Differentiation topic is completed. Uh, Now from the exercise 3.6, you try to solve that question number 2. Okay. Thank you.